Assalamualaikum warahmatullahi wabarakatuh. We will tell my big task, Discrete Mathematics, about relation. Let me introduce my group. My name is Mochammad Rizal and my friend is Muhammad Arafat al-Mubarok. Now relation. We suppose that E and F as a set. The relationship between the set E and a set F is a set that has a suppose or letters or numbers sequentially but follows certain rules. Thus, a binary relation R between the set E and F, set from E cross F or R cross on E cross F. For example, suppose E equal 2.4.6 and F equal 2.4.2.6.8. If define relation R from E to F using such rules, E dot F equivalent R is the factor of F, and as you learn earlier of as you know, E cross F B. E cross F equal 2.2, 2.4, 2.6, 2.8, 4.2, 4.4, 4.6, 4.8, 6.2, 6.4, 6.6, 6.8. If using a rule relationship or relation above, relation of R from E to F that follow the rules have become R equal 2.2, 2.4, 2.6, 2.8. Relationship or relationship can also appear on only one or a set, namely this relationship in E in the set A with a set E cross E.
Application of relation. Number 1, association of sequential pair. Number 2, a row diagram. Number 3, Cartesian diagram. And number 4, with formulas. Number 1, association of sequential pair. The set whose members are all consecutive pairs on x dot y is called the set of sequential pairs. If x and y element E and element F, the relation of E to F can be expressed by a sequential pair on x dot y. Of the arrow in the diagram above can be written as a set of pairs in a series 1.2, 1.4, 1.6, 2.4, 2.6, 3.4, 3.6, 4.6, and 5.6. Number 2, a row diagram. Step by step how to express the relation with a row diagram. E. Create two cycle or ellipse. B. Place members A and members B. X equal A is placed in cycle A and Y equal B is placed in cycle B. C. X and Y are connected by a row. D. A row indicates the direction of the relation. E. The arrow represents the rules of relationship. You can look at the picture. This is a row diagram with plus than. You can look at domain have 1, 2, 3, 4, and 5, and codomain have 0, 2, 4, and 6. You can look at 1 plus than 2 plus than 4 and less than 6, and 2 less than 4 and less than 6, and etc. Number 3, Cartesian diagram. In the Cartesian diagram, refer to cross x, namely cross axis and vertical axis with intersect perpendicularly. E. X equal A is placed on horizontal axis. B. Y equal B is placed on vertical axis. C. Insertion on x dot y is marked with a dot that is written as a pair sequential coordinate on x dot y. Number 4, with formulas. Function x equal x plus 1, where x on 0, 1, 2, and 5. And function x on 1, 2, 3, 4, and 6. You can look the example in this picture.
Attribute relationship. 1. Reflexive. 2. Symmetric and antisymmetric. 3. Transitive. 1. Reflexive. A relation R on a set E is called reflexive if on E dot E equivalent R for every E equivalent E, and can be referred to relation R on a set E is known to be a reflexive if E equivalent E, and so is if on A dot A not equivalent R. For example, let E equal 1, 2, 3, 4, and the nature of the relation R is less than which is exemplified set E. So R equal 1.1, 1.2, 1.3, 1.4, 2.2, 2.3, 2.4, 3.3, 3.4, 4.4, not feasible if 1.1, 2.1, 3.3, 4.4 is an element of R. If so, R regards set reflexive. Number 2. Symmetric and antisymmetric. A relation R on the set E has the symmetry properties if E dot F equivalent R, if F is E dot F equivalent E. So, the on E dot F equivalent R, a relation R on a set E is said to be symmetric if E dot F equivalent R, while the E dot F not equivalent R. In a relation R, compilation E has antisymmetry, and suppose that for every A dot B equivalent A dot B equivalent R and B dot A equivalent R is recognized if A equals B. Not if the term or definition symmetry and antisymmetry is not the opposite, because a relation can have both qualities at once, but a relation cannot have both qualities if we have or have a suppose or unordered sequence with form on A dot B where A not equal B. Now see, for example, prove if the relation less than is the set Z that is antisymmetric. So if E less than F and F less than E means E equal F. The result is less than to be or has antisymmetry. Number 3. Transitive. Or a relationship of R on a set E has a transitive nature when A dot B equivalent R and B dot C equivalent R. Then A dot C equivalent R for A, B, C equivalent R. For example, suppose E equal 2, 3, 4, 5, 6, 7, 8, and 9, and a relationship can be defined if E, R, F, if and only if E divides F, where E, F equivalent E. And if we look at the definition of R is contained in the set E, so R 2.2, 2.4, 2.6, 2.8, 3.3, 3.6, 3.9, 4.4, 4.8, and when 2.4 equivalent R and 4.8 equivalent R. We find then when 2.8 equivalent R and R is transitive properties. Examples of problem and relationship discussion.
Problem 1. Let S equal 1, 2, 3, 4. Note relation R1, R2, and R3 on S. The followings R1 equal 1.2, 4.3, 2.2, 2.1, and 3.1. R2 equal 2.2, 2.3, and 3.2. R3 equal 1.3. Determine R1, R2, and R3. Completion. E. Symmetrical. R1 is not symmetrical because members 4.3 know 3.4. R2 is symmetrical because members 2.3 there are 3.2 and 2.2. R3 is not symmetrical because the only members 1.3 and no 3.1. B. Transitive. R1 is not transitive because there are members of 4.3 and 3.1 but no 4.1. R2 is not transitive because there are members of 3.2 and 2.3 but no 3.3. R3 is not transitive because R3 has only one element, namely 1.3. Problem 2. Change relation of the following table to represent the relationship with the arrow diagram. Completion. Each element of the set A has the corresponding relation to each element of the set B. The completion arrow diagram image. Emir, Mathematics and Mandarin. Yuda, Mathematics and Japan, and Gesta, Biology.
Problem 3. A equal 1, 2, 3. B equal 1, 2, 3, 4. Relation R equal 1.1, 1.2, 1.3, 2.2, 2.4, 3.4, and 4.4. Inversion of the relation R is completion. Inversion of the relation R is the relation denoted by R inverse. The set of R, namely those from B to A, is defined by R inverse equal B dot A, where A dot B equivalent R. Problem 4. 4 students choose favorite subjects respectively. Adit choose mathematics and electronics. Chandra selecting information systems and databases, while Joseph choose physics, mathematics, and English, as well as Dina choose electronics and English. What the sequential relationship with the set of pairs? Completion. Adit.mathematics, Adit.electronics, Chandra.information systems, Chandra.databases, Joseph.mathematics, Joseph.physics, Joseph.english, Dina.electronics, Dina.english. Problem 5. A equal 1, 2, 3. B equal 1, 2, 3, 4. Relation R1 equal 1.1, 1.2, 1.3. Relation R2 equal 1.2, 2.2, 3.2. Then R1 U R2 is completion 1.1, 1.2, 1.3, 2.2, 3.2. R1 UR2 is a union relation R1 or R2 combined with the relationship that every element in each set are combined, but written once for each element of the same. This is the end of the presentation. Thank you very much for your attention. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.